Hey David,
Yeah?
I have a question.
What?
What is momentum? I
Oh.
can't seem to understand it.
Well, momentum is basically how much inertia something has and how fast it's going. Like, it's summed up in the formula P equals mv, with P being momentum, m being mass, and v being velocity.
Oh, I see. Let's take a car that is standing still and a bicycle going around. What do you think has more momentum? The car has
More mass, right? But the velocity would be zero, so it's not moving at all.
Alright, so when the car is moving and the bicycle is moving, which has more momentum?
The car.
Right, because the car has more mass, means mass times velocity would have more momentum. Do you want to make an experiment?
Impulse is how much force is applied over how much time.
Let's say I'm gonna punch you, alright?
Okay.
And I'm gonna punch you as slowly as I can with more time though. That wouldn't hurt. But if I'll punch you real hard, it would kinda hurt, right?
Yeah.
More time, less impulse, and less time, more impulse, correct?
Yeah, let's just hope you don't get hit by Chuck Norris. So basically, in the absence of an external force, the momentum of the system doesn't change. So the momentum before and after the movement between the two objects in the system would stay the same. We got these two guys, they're part of a system. When this one starts moving, it's got momentum, and it just transferred the momentum.
In conclusion, momentum cannot be destroyed nor created, correct?
Exactly.
And so it has to be transferred to something. So everything has momentum basically.
Why is it that it seems like sometimes momentum isn't conserved?
In some cases, things happen way too fast for us to react and to really feel that momentum is conserved. For example, if we shoot a bullet from a gun and the bullet penetrates a tree, a big tree, a massive tree, we wouldn't see the bullet moving the tree at all. It is moving just a tiny bit. We can't see it's moving, but it is just moving just a little bit.
In that case, when is momentum conserved?
Well, David, you have to remember, momentum is always conserved.
Oh yeah, right, with the law of conservation of momentum.
Yes, because momentum cannot be created nor destroyed.
So, if I have this right, elastic collisions are collisions where colliding objects rebound and there's no permanent change in their shape.
Correct. A good example would be taking a rubber ball, let's say like this one, alright? When you throw it to the floor, would it bounce back?
I'd hope.
I'd hope, right? Alright, so let's do it. It did bounce back, right? So, this is elastic collision.
There's also inelastic collisions where the shape would be changed and they might even stick together.
Yes, let's take a break. If you would just let it go from there to the ground,
It's not going to bounce back.
it's definitely not going to bounce.
Also, like, I guess the shape changes in elastic collisions, right?
Correct.
Like,
But then you put it back together and boom. Alright, you got it?
yeah, I think I'm ready for this test.
Alright man, it was really good setting with you, thank you.